In this lesson and tomorrow, we're going to practice using transformations, which are rotations, reflections, and translations to draw tessellations. So a tessellation is pretty much just a tiling of the plane. So you have a pattern that repeats and it fits together nicely so that there are no holes and gaps, and it completely covers a flat surface without any overlapping. One of the things we know about tessellations, or for any shape that will tessellate, is that all of the angles have to fit together perfectly so that there's no overlapping and no gaps. So all of the angles that meet at any vertex of a tessellation have to add up to 360 degrees so that they can tessellate properly. So here is examples of tessellations. One is a regular tessellation, and a regular tessellation is just formed by congruent regular polygons. So if you think about the problem where my daughters are talking about us being in a dead zone, and my older daughter said, well, why don't they just make the region, instead of a circle, make it a hexagon? She was thinking that then there would be no gaps, and therefore you would be creating a tessellation, similar to the figure that you have here. Now, a semi-regular tessellation is formed by two or more different regular polygons. So the one here that is green, blue, and white is made of squares, it's made of equilateral triangles, and it's also made of, there was something else in here. Oh, there's a rhombus, I believe. Yep, there's a rhombus here, a rhombus here, a rhombus here. So those three shapes, and actually, I disagree with something they said. It says it's formed by two or more regular polygons with the same number of each polygon occurring in the same order at every vertex. I would say that that is not a regular polygon because all of the angles are not the same. But the square and the triangle definitely are. So yeah, they're a little loose with their definition here. But at any rate, that's what they're considering a semi-regular, a partially regular tessellation. All right, so let's classify these tessellations as regular, semi-regular, or neither. I'm looking at this first one here. I would say neither because that is not a regular shape. Here, if we're looking at this one, I would say this is a regular tessellation because those appear to be equilateral triangles. And here, because we have a square, we have a triangle, and it looks like we have a hexagon, I would say that this one is semi-regular. All right, now it's important to know that not all figures can tessellate. Remember what we said about the angles where they meet at any vertex? All of those angles have to add up to 360 degrees. So given this particular figure, could we come up with a tessellation? Well, it looks like a regular triangle, so all of the angles would be 60 degrees. So I think that we could definitely tessellate this figure. The tessellation, that's not good. Could look something like this, and all of those angles add up to 360 where they meet at the vertex. Now, how can you decide whether or not a figure will tessellate without drawing it? Well, you just take the angle and see if it's divisible by 360. If you can do 360 divided by 60, and it's 6, it comes out even, then yes, it will tessellate. So if we look at this, what's the angle for this regular polygon? Well, it's the sum of the interior angles is 360, and we divide that by 5 because there are 5 of them. Ooh, and that's not the sum of the interior angles. My bad. It's n minus 2 times 180. That was our equation for the sum of the interior angles. So there's 5 minus 2, so it's 3 times 180. So each of these, the interior angles sum up to 540. Now each of them individually, if I divide by 5, is 108 degrees for each individual angle. So now I want to see if 108 will divide evenly into 360 because if it does, then it will tessellate. We can put all the angles together. So if I do 360 now divided by 108, And it's not going to work, I can tell you that now. But if I do that, I get 3.333 repeating. So no, it will not tessellate. Now, will these guys tessellate? Is it possible to put a combination of these angles and these angles together? So this is a 1, 2, 3, 4, 5, 6, 7, 8-sided figure, which is an octagon. So we do 8 minus 2 times 180. So we got 6 times 180, and that is 1080. Divide that by 6. Oh, no, divided by 8. 1080 divided by 8. And that would be 135. So for each angle in there would be 135. And then each angle here would be 90 degrees. So is there some way to combine the 135 and the 90 to get 360? I'm going to do 360 minus 135. And that would be putting one octagon there. Minus another 135. And that will be putting another octagon there. And then I have 90 degrees left over to fit a square in. So 2 times 135 plus 90 would equal 360. So yes, you can put those together. You would have, oh, I'm not good at drawing octagons. One octagon there, and then maybe another one here. And then you could have a square right in there, and then another octagon coming off, and so on and so forth. And you can continue to tessellate that. Another octagon with a square in there. Okay?